What's up, everybody? Welcome to another episode of Let's Ask Paul, the podcast where you get to ask me, Paul Abernathy, anything you want about the National Electrical Code and all things electrically related, and I will give you my opinion. You can agree to disagree, but at the end of the day, it's my opinion. I own it, and I will give that opinion to you. If you would like to send for an opinion to NFPA, you're free to do that. It carries no more weight than mine. But I am giving you my thoughts and my insights on different things that are asked of me here at paulabernathy.com. So that is the portal where you can submit questions. Just go to paulabernathy.com and you'll see a pretty simple format for you to be able to ask questions. So do me a favor, just go there and feel free to ask questions. A couple announcements that I'm going to make in the Let's Ask Paul podcast before we get too deep into it. You may notice that we have discontinued a lot of merchandise from our website. So if you were thinking of buying the hoodies or the shirts or hats, and they were pretty neat engraved products, or not engraved, embroidered products and pretty good quality stuff, and you say, ooh, I just drug my feet. Well, too bad. They're gone. We just are not going to get into that. Again, it didn't make us enough money. We weren't in it for the money. When it came to those products. But in many cases, we barely made $1 or $2 on everything that was sold. But we incurred the issues if somebody had a problem with something. So it's just not worth it. So we do have merch up there. We have our engraved coins, our engraved wallets, the minimalist wallets. We have coasters, other things that we engrave here in-house available. Our conductor length cards, our voltage drop cards, all those type of things. And we'll have many other types of things coming out, but that's where we're going to draw the line. We're not getting into any of those other products. And the other reason was the prices changed so much from import, and since they were made to order, the prices fluctuated, and many times we even lost money on a sale. Well, that's not a good way to do business, right? So we're just not risking it anymore. There wasn't enough in mass volume. If it did a couple $1,000s a month, that was great. And people say, hey, a couple thousand is a couple thousand. But it really wasn't in the scheme of the way we work. It's just not enough. So it's too much trouble. So we just discontinued it. So if you've ever wondered where it happened to that stuff, it's all gone. Now, you can go over there. It's in our store. You can see our engraved products and things that we have over there, still there. But we just are not going to deal with things like shirts, hats, hoodies, all that kind of stuff. And don't ask, because if you snoozed, you lose. If you didn't buy it up to this point, then it is what it is. You can't buy it. It's gone. Okay? Just want to get that out there. All right. Now, we do have some unique designs, and we might make our designs available at some point for somebody to be able to use it and get their own stuff made. That is what we're looking at, because we do like to design stuff, and we have a lot of designs and logos for master and journeyman electricians. But at this point, don't ask, because we're not there, and we're not sure we're going to even do that. All right. Anyway, that's what we got going on for that. All right. Also, secondly, you may notice that there's a little bit of a redesign on the website. It's just a little nuance in how you would navigate to the exam prep courses, databases, and other resources. Just changing it up a little bit. You may or may not like it, but it's a little more colorful look to the mobile. If you go to the site on the mobile. But anyway, it is what it is. We're just kind of making some subtle changes. All right, today we're going to be talking about a question that was submitted to me in the Let's Ask Paul, was asking about pull boxes or a metal wireway that is imposed on a raceway run, and whether or not you had to meet the pull box requirements, even though it was technically not a pull box. And everybody likes the code to be pretty much black and white. And, I tell you, when it's written a certain way, I wish that everybody would enforce the code a certain way. But in reality, some people look at something and they bring up questions and they say, well, what if? So at the end of the day, the AHJ, some things are just black and white, right? It's just point blank. It has to be a certain way. But there's some things that could be argued. And there's some things that you could create an argument for or a position for. And again, the AHJ, authority having jurisdiction, the inspector who is working on behalf of the actual AHJ, or maybe it's the building official or the administrator for the county, whoever's done, doing codes and enforcement. At the end of the day, they have the ultimate say. That's their responsibility. NEC is just a document. If it's not adopted, it's not enforced, then it's really, what's the point in it, right? So that's something we have to keep in mind. So in this case, the question, I'll read the question, and I'll tell you that, and I've already emailed this individual, and I've gave them my position. There's two ways to look at this, and I'm going to give you the practical way that I would teach it. And I remember for years, I was the kind of devil's advocate kind of guy, and I remember Phil Simmons telling me one time, he says, Paul, don't tell people the other way, just tell them the way it's supposed to be, and that means that's the way that I thought it would be. And he's like, that's enough. And where I always would give you what it's supposed to be or what I thought it was in the code, and then I'll give you the devil's advocate response. And again, you can say, well, shit, you just tell me what I'm supposed to do. And I don't like to do that because I think all the people out there that listen are free thinkers. Obviously, if you look at social media, everybody's got an opinion. And I just have an opinion. And I'll share my opinion, and you can agree to disagree, and that's fine. And you could say I'm full of crap. That's fine too. I don't really care. At this point in my life, I really don't care what anybody thinks of me, really. So it is what it is, right? I'm on the downswing of life. If I could retire tomorrow and not do anything, I'd just do it. All right, let me read this out to you. So here's the question. It says, I have a question about Wireway. If I install a 12 by 12, and I'm assuming he means 12 by 12 inch, I guess, metal Wireway above a 400 amp panel board, okay, it says a 3.5 or 3.5 trade size EMT is passing straight down through the Wireway on the 12-inch side to an 18-inch nipple to the panel. So basically, it's got a 3.5 trade size EMT coming in through the top, coming into a Wireway, and then coming out of the bottom of the Wireway with a nipple that goes to the panel. We'll assume the nipple is the same size, 3.5, which is still just a raceway. There's no definition of a nipple in the NEC. We make references to length, but at the end of the day, an EMT nipple is still just EMT. It's still a raceway. It just happens to be a shorter one. Now it says, I only have 2 90s in the run, so I don't need to use the 360 degree. Okay, that's what he says. And it's a little grammar issue here, so I'm just going to paraphrase it so y'all understand it. Okay. Now it says, does the Wireway have to be 8 times the raceway's size? As stated in 376.23b, has me concerned. Wireway fill is not the concern. I appreciate all you do for us little guys out in the field. Hey, y'all is what make the world go around. Okay, it's just little, people like me that opine on this and that. But at the end of the day, y'all are what get it done. So again, don't ever feel little guy. Y'all are the ones that get it done. We're just here to support you. Okay, that's important. So let me answer this question. And the only way to answer this question is how we logically would look at the installation. If somebody, and I've had this happen before, if somebody's pulling conductors in a raceway and they are going to be exceeding 360 degrees worth of bends, whether it's offsets or whether it's 90s, whatever it may be, then they will install a box in there in order to meet the pull box, to meet the 360 rules, right? No more than 360 degrees between bends, between points, right? Pull points. Okay, so the logic always was we'll put the box in there, then we comply with the code, okay? So let's say they were 380 degrees worth of bends. Okay, so somewhere in there before those last couple bends, they'll put in a box. And their argument is, and people's argument is it a pull box? I mean, at the end of the day, am I going to pull out of it? Well, obviously, as far as the code's concerned, it's a pull box so that you don't have more than 360 degrees between pull points. It does not dictate that you use it. That's a code rule. So you put the pull box in. You're probably still going to pull straight through it, provided you've done a pull calculation and you know what to do with the pull calculation. And by the way, we do pull calculations for people, okay? So at the end of the day, when an inspector looks at that, it's whether you use it or not, it's still a pull box. You literally are pulling conductors through it. Now, whether you use it or not is irrelevant. So with that said, under those rules, you would have to put a pull box in there or a box in there that meets all the rules that be required as if it was a pull box, okay? You'd still have to meet those rules, right? So you have these rules in 314.28, and they talk about straight pulls, straight is 8, or angles, or splices, it's 6 times the largest raceway. Now, with the angles, it's plus the sum of the other raceways in the same row. on the same side. So all these rules would still be in play, regardless of whether or not you use the pull box, or you don't even want to call it a pull box. The reality is, if conductors are passing through it, it could conceivably be used as a pull box. So you have to meet the requirements of 314.28. Okay, it just is what it is. Now, the question comes up, and it's like this one, where the gentleman says, we put a wireway up there that's interposed into the raceway run. We're not doing it to meet the because we have an issue with 360 degrees of bends between pull points. We don't have an issue with that. We just wanted to put a wireway up there for whatever reason. Okay. And so you call it not a pull box. You just say, I just put a wireway up there. I mean, that's what you're saying. Okay. So if you're going with me down this chain of thought, we're going to look at that. Now, in doing so, we're going to have to go look at Article 376. Now, 376 is dealing with wireways. Okay. And so, because he said this was a metal wireway. So that's what we're dealing with. Now, if you go look at 376.23, which is titled Insulated Conductors. Okay, so we're talking about insulated conductors, THHN, THWN-2, XHHW, whatever, insulated conductors. It says that insulated conductors installed in metal wireways shall comply with 376.23A and B. Okay, so it tells us right off the bat, if you're installing insulated conductors inside of a wireway, you're going to have to meet the rules of 376.23A and B. Now, A is dealing with deflection of those insulated conductors, okay? So that is where the conductors come into the box or come into the wireway, all right? Either ends of the wireway or whatever, and how it moves through the actual wireway and the deflection of those conductors, okay? So as they come in, enter, and leave, or where the direction of the metal wireway itself is deflected greater than 30 degrees in dimensions, then you have to follow the requirements of the one wire per terminal in table 312.6a shall apply. So you have deflection rules, and we have a table that deals with deflection rules, okay? And you use the spacing. It's one wire per terminal. And I think I've done some videos or training on that deflection. Not the topic of this question, though. It's not about deflection, because in this case, the raceway came into the top of the 12 by 12 wireway and came straight out of the bottom of the wireway. Okay. So the question is that a pull box? Is it just a junction box? What is the purpose of the box? Okay, and then we're also going to think from an inspector's perspective. If I'm looking at it, I'm wondering, why the hell did you put this box in there? So you have to ask yourself some important questions about this. Now, here's what it says in B, 376.23b. It says, metal wireways used as a pull box. Now, a lot of people will look at that charging statement and immediately will say, and here's the devil's advocate, you ready? They'll say, well, this gentleman put this box in here, but he's not using it as a pull box. Therefore, this rule doesn't apply because it's not being used as a pull box. Well, the question about that really comes into the fact that even when you're looking at 314.28 A1 and A2, and you're looking at 8 times, and okay, that's the requirements for dimensions of the box that's used as a pull box, okay? But it doesn't go short in defining in the NEC what the hell a pull box is by nature. So any box that I pull conductors through it can be argued as it's a pull box, right? I mean, that's what we're talking about. Not just for you to pull in and conductors in and out during a raceway pull application. I mean, that's the most practical reason. But at the end of the day, what did I say? I said if you had a raceway and you were going to exceed 360, the way you do it is you drop a pull box in there. Whether you use it or not, it goes in there and to meet the code requirements so that you don't have more than 360 degrees between pull points. So you're just putting the box in there as an exercise. You're probably going to pull it straight through that box, okay? Unless there is some type of deflection you got to worry about. But normally you're going to pull it straight through the box, okay? So by pure nature, it's a pull box. So when you read this, there has to be the devil's advocates. And again, this may be your argument. If you run into this in your jurisdiction and you have an AHJ that will listen to you, then you can argue this says this rule only applies when metal wireway is used as a pull box. But the sheer fact that you're pulling conductors through it, whether you use it or not, for a pull itself, it's still a pull box, okay, as far as those are concerned. So here's what it says. It says, where insulated conductors of 4 AWG or larger are pulled, listen to how it says, pulled through a wireway, okay? It says, and remember, the title is one thing, it's the charge, it kind of sets the tone, but the code language is the code language, and I'm reading you the code language, okay? Not just the header, but the language. It says, again, where insulated conductors of 4 and larger are pulled through a wireway, comma, the distance between raceway and cable entry enclosing the same conductors shall not be less than, that means they're coming in and passing straight through into another wiring method, okay, another raceway or whatnot, or cable assembly. It says, shall not be less than that required by 314.28A1 for straight pulls, which is 8 times, and 314.28A2, which is 6 times for angle pulls. Okay, we're transposing cable sizes into a raceway size, the minimum metric designator or trade size raceway required for the number and size of conductors in the cable shall be used. So that basically means that if you're using an MC cable, look at the number of conductors, look at what insulated conductor, look what's in there, and then do a calculation as if it was a raceway. You choose whichever one you want, okay? But you find a raceway, and to make sure that that's what's going to basically give you the size, trade size, like if it was a raceway, even though it's an MC, and that doesn't come in trade sizes like that. You don't do it the same way. But if all the conductors in an MC cable, let's say, were being used in this box, going through this wireway, and it was MC, and you're trying to do the numbers in order to meet the 8 times or 6 times, depending. In this case, it would just be 8 times because it's a straight through pull. Then you would determine what would be the size raceway. And usually we would use the same size of the raceway if it's coming in. Like, for example, if it was EMT coming in, but it was MC going out, then we're going to basically calculate it out on what would be the minimum size raceway if it was EMT, because that's what's feeding it. Now, if it's all MC coming in and MC going out, then you just have to pick and say, okay, I'm going to use EMT, and I want to find out what would be the minimum size I would need to be able to hold all these conductors and not exceed the 40% fill. And then that's the size raceway I go with, and I would do that times 8, and that's my dimension, okay? Or in this case, since it would be MC, then it wouldn't be a straight through, it would be splices. So it would be 6 times, obviously, in that example. But you get the point. So it's my opinion that regardless, if you transpose and you put a wireway in between a run, and your only effort is to pull straight through that wireway, then I believe that it is being used as a pull box. You do have the ability to pull it from there, okay? That's what I believe, all right? So as a result, I think you have to meet the requirements of 314.28. A1 or A2, the 8 times or the 6 times, whether you're angle or splices or you're straight as 8. And so adding the pull box and saying, or adding the box, or in this case, the wireway, and saying, well, I'm not using it, then what did you put it there for? I mean, what's the purpose? If the conductors are passing through it, then they're being pulled through the box. So your only argument to an AHJ is obviously if you put this wireway in there, and in this case, it was a 12 by 12, which I don't believe is going to be adequate, because if you follow the rules, again, he said it was a 3.5 or 3.5, so 3.5 times 8. It needed to be at least 28 inches in straight from top to bottom, not the width, okay, because there was no angle pulls mentioned, anything like that. So in this case, it's just the width of it is to accommodate the raceways, and the depth of it was to accommodate the raceways and the lock nuts or whatnot, right? So this case, it was a straight pull through. So I think that your box, your wireway, whether you intend to use it as a pull box or not, it is my belief that that still has to meet the requirements. And that's why it makes references back to 314.28, where you get the A1 and A2. I think that's the intent personally. And in researching it and looking at it a little bit from other people that I know and looking at that, they kind of gel with the same kind of interpretation that I'm giving for that. You can agree to disagree. Again, it falls back to me. It falls back on the question: what did you put the Wireway in there for? If you're coming in with a 3.5 or 3.5 or a trade size 3.5, coming into the top and coming straight out the bottom, even if it's a nipple, 18 inches, the question is, what did you put that box in for? So if they're insulated 4 gauge and larger, then to me, you're putting it in as a perceived pull box, whether you use it or not. It's going to have to be perceived that way. And I don't know any other way that the electrical inspector can't look at it. I mean, especially if it's not put in there, for example, like I said earlier, people put boxes in when they know that they're going to have more than 360 degrees worth of bends between pull points. So what do? They put in a pull point. They'll put it in. Now, whether they use it or not or pass right through it, pull it, they probably aren't going to use it. But it still would need to be the proper size regardless, because it could be used as a pull point, right? So at the end of the day, I think the AHJ inspector is going to have to make the call and say, you know what? It is plausible to be considered a pull box. You are definitely pulling conductors through it. I don't control what you do after I'm not here, so it looks to me, and so it doesn't meet the dimensions that are required for a pull box in this situation. So again, that's where I think that most of the AHJs are going to lean, and the box is too small, or the Wireway is too small. Okay. All right. Hopefully I answered that question. That's my opinion. You can agree to disagree, but that's my position on it. I believe that you are going to have to follow the requirements as if it was indeed being used as a pull box, that type of thing. Okay. All right. That's my opinion. You can agree to disagree. What's next? Okay. So the next one we've got here is one that's actually asking for my opinion. So I will give an opinion. I will say up front on this one, just so you know, I am not an expert in HVAC equipment. I am not an expert in the HVAC standards, like UL 1995. I don't have anything to do with that industry. Okay, so this is just asking me a question, and so I can only answer it based on what I know from the NEC. And there seems like there's a mechanical industry, the HVAC industry, that has a disconnect, pun intended, with what we do. So let's talk about it real quick. So here's the question. It says, EE from New Jersey here. I love the podcast, but I am a new listener. So my question may have been answered on a previous podcast. Please point me to that release date and I will listen. Okay. Well, I can tell you, based on your question, it has not been discussed at a previous date. So I can only talk to you about what I know as of today. And again, I am not up on other industry standards as well as you may be as an engineer who may design systems. Then you're constantly looking at these things. I just follow the NEC. I'm just an NEC guy. Okay. So that's all I can follow in this scenario. So let me go on and read it to you. It says, I would love to hear your take on the SCCR, and for those that aren't familiar, that's the short circuit current rating that we typically see on electrical equipment. You have a panel board inside of a cabinet. Typically, you would have an SCCR rating on the cabinet, and in the panel board, in all of that together is going to give you an SCCR rating. And then, of course, you have like overcurrent protected devices. They give you the AIC rating. All of this is covered in 110.9 and 110.10 of the National Electrical Code. Okay. That's to the extent that I involve myself when it comes to this type of thing, okay? I assume when I purchase a piece of equipment that I know what the available fault current is at the location where I'm putting the equipment, and I get my equipment accordingly. I might have to specify a certain SCCR rating on a piece of equipment as well as the AIC rating if there's overcurrent protected devices involved. I have to make that selection, because I have to be fully aware of what my available fault current is at any point in the system, especially now more in the NEC as it expands out for us to require labeling and all this type of stuff in order to be able to tell somebody what the SCCR rating is, what the AIC rating is, what the available fault current rating is. All this kind of good stuff seems to be expanding throughout the NEC. So manufacturers need to be more diligent, obviously, on giving information on equipment, whether it's on their nameplate, data sheet, or whatever, because we're getting more and more intricate in how we design systems. And the electrical engineers who are having to design these systems are having to look at all these things. And sometimes certain things doesn't gel very well with other industries, okay? So he wants my take on this, and it's about the SCCR rating for HVAC equipment. Now, he says HVAC equipment usually has an SCCR rating of 5,000 amps, and the available fault can pretty commonly be higher than this for larger equipment. It says, I always called for fuse disconnect switches to limit the let-through, but what I am learning is that there could still be a fraction of a second where the unit sees the higher current while the fuse clears the fault, and the right way to do this is actually request the HVAC unit to be listed with a higher SCCR rating. That is absolutely correct. And in many cases, we talk circuit breakers all the time, and their minimum ratings and then series ratings and all this type of thing. And then we've also talked about that where the available fault current, as it gets further in to a structure, will start to diminish, right? Because of impedance and the other things that it has to go through. So it starts to go down. So it doesn't typically get higher. But depending on where this equipment's located, close to the source, again, can have an effect on the equipment. So the right thing to do would be to review all this, look at the available fault current, and it's just more that the engineer is going to have to be aware of. And I would kind of tell the electrical engineers, and you need to push back a lot against the mechanical engineers and the manufacturers of HVAC equipment if they're going to be installed at a point in the system where the available fault current can affect what might be a posted SCCR rating on a piece of equipment, or if it has an overcurrent device in there, an AIC rating on a piece of equipment. We have to push back. You have to push back. Now, when we're thinking about it, it's a real world problem, right? Is that most of the HVAC equipment that I'm aware of and what little research I've done, you have the commercial package units, the rooftop units, the VRFs and the VRV outdoor units. All of these are factory. And from what I'm seeing, and again, I'm not an expert, but what I'm seeing is a lot of those do come with an SCCR rating on the equipment at 5K VA, okay, or 5,000 amps. Sorry, I was going to say VA. 5,000 amps, right? And so I'm seeing that's pretty common, unless they're marked otherwise, or unless it's a specific piece of equipment that's being made and have it evaluated at a higher amp rating. Okay, higher amp rating. Getting all tongue-tied today. So now the lower SCCR rating is often a problem, because it's typical for an available fault current on commercial buildings, depending on where this HVAC equipment is located, to be as high as 18,000 up to 65,000 amps for a specific period of time of this available fault current, and assuming that the equipment can handle this. Now, it's typically what we look at is if we have, and what they'll argue is that what we have is the main equipment that's coming in is typically going to have a higher amp rating, right? So you're going to have the SCCR rating on the equipment where the service comes in, and the overcurrent protected devices, an AIC rating, are going to be more than adequate to handle the available fault current from the utility that's supplied at that point. And as it goes downstream into the building, this number is going to decline, right? So this is kind of one of those things where if your equipment upstream is series rated, and so you have all this series rating on the overcurrent and all that type of stuff, then it typically will trickle downstream. And it may be, and I don't know the answer to this, it may be the question needs to be asked to the manufacturer if this SCCR rating that they're putting on their equipment has factored in the fact that you have an SCCR rating on equipment that's at the service, and in the AIC ratings on various overcurrent devices will dissipate further as it comes into the building. And the question is, have they taken that into consideration when they did their 5,000 amp SCCR rating on the equipment? They may or may not know that answer. And it also does not mandate the fact that that equipment is probably not having anything to do with anything remotely near series ratings. So again, it's just me speculating because that's how it typically works with the overcurrent protected devices and all that kind of stuff. When you did a series rating in a panel board, for example. So I'm just purely speculating on that aspect, but that's a good conversation that needs to be had with the manufacturers of this HVAC equipment. Again, the commercial package units, the CPUs, the rooftop units, the VRFs and the VRVs that are outdoor units, all those type of things. These are conversations that really do need to be had with the manufacturers of those equipment. Now, the one question I will tell you that why fuses don't actually solve this, they may help the issue, right? But they don't necessarily solve this issue, because if you select the properly selected current limiting fuse, for example, now it may mitigate the energy, the let through, right? But it does not for any reason increase the SCCR rating on the equipment to which it's installed or installed in conjunction with. So while you may be doing this to solve a problem, this does not change the SCCR rating or that's on the label of the equipment in any way. So this is just being a proactive step that is being done by the design professional. And they have every right to do that. And again, this is what this gentleman has done in order to mitigate some of the risk here that's involved. But I will tell you that does not, just because you install fuses in line, that does not increase the SCCR rating of any of the equipment. In fact, most of the HVAC equipments and nameplates don't even recognize any fusing in the field as a valid solution to increase any SCCR ratings on the equipment. It's not something they're going to take into consideration, right? And if you go look at the various standards, UL 1995, for example, for HVAC standards, unless they mandate something or stipulate that a fuse in line or something like that will raise the SCCR rating, unless they give you some scheme that you have to do that, then the fact of the matter is that you're stuck at 5,000 amps, and that's it. Now, again, it may be a diminishing factor where you put it on the system. Maybe while we're not seeing a lot of issues with this, I mean, I'm not assuming this engineer is seeing a lot of these issues. Sounds like he's mitigating it out by putting fuses in there. But it doesn't necessarily mean the fuse is going to cause the problem, because before the fuse clears, you have a high level of this fault current that could still cause a problem on the HVAC equipment. So again, figuring out how the fusing works. But again, that's not going to change the manufacturer's SCR. So what you're doing is you're doing something that you hope will mitigate the risk to the best you can. That's about it. But the manufacturers seem pretty silent when it comes to that. Now, why it matters as far as the NEC is concerned? Well, the NEC 110.10 requires that equipment interruptive capacity be suitable for the available fault current. Okay, so that requires that the equipment, and so at this point, it's in conflict with the manufacturer's statement of 5,000 amps. Okay, so again, next is the 110.9. That applies to the overcurrent protecting device. But again, HVAC units have built-in controllers, contactors, control transformers, all that kind of stuff that must be protected, not just a disconnect or a circuit breaker. Okay, so the 110.9 is more specific to overcurrent protected device, but there are obviously other things within the componentry of these units, these HVAC units, that need to be protected. So a 110.9 does not specifically address the internal or any other type of component that's built into the actual HVAC unit. Okay, now, one of the things that we have to worry about is if you fail to coordinate any SCCR rating, then what happens, it could lead to bigger issues, okay? And it could lead to where the available fault current at this piece of HVAC equipment was far exceeding the 5,000. Now, like I said, I'm going to be totally honest here. I have not heard of any major issues here. I really haven't. Now, what could that be for? Well, it could be that we just have solid systems that are not seeing the faults. We're not seeing available fault condition. We're not seeing, these things that would bring question to the installation, and that's not the resiliency of the products. That's probably the testament to the engine, the design, and the people that are installing it. Maybe that type of thing. They're just doing a better job now. But I imagine if you had a lot more of events that took place, then you got to question who's liable. Is it if the available fault current was higher at the HVAC equipment and it was only 5,000 amps and somebody got hurt? Is it the engineer's problem? And this is why this engineer is installing these fuses to try to mitigate as much liability probably as possible. Is it the manufacturers of the HVAC equipment that's liable? It's certainly, you got to question, is it the installer? Because the installer needs to know what the available fault current, and if he's installing something on a system and it is far less than the available fault current at that point, can he actually install it? But it gets done all the time, right? So the one thing about the designers here is they rarely ask for any SCCR documentation from an HVAC rep. I'm probably never do that. They probably never ask the people that are going to supply the equipment and say, hey, what is your documentation? What is the SCCR rating? If I need a higher rating, what can I do? Is it special equipment? It's kind of akin to, I tell people all the time, with MC cable, cable, people want to run it in parallel and they want to know why the equipment ground's not large enough. And I'm like, because we don't make MC cable for it to be run in parallel. You're choosing to run MC cable in parallel. We manufacture MC cable to be protected at its ampacity for the conductors that are in it as a single cable assembly, not to be installed in parallel. That doesn't mean you can't do it, but this is where you run into the problems with an undersized equipment ground. Now, yes, we have some allowances in 251.22F that can help us do that by running a single one and connecting all ends together and yada, yada, yada. We have some provisions that over the years we said, we got to do something because, we can't make a special MC for everybody or a special tray cable for everybody. So we have to come up with some allowances, okay? Same kind of scenario here. Where this is a situation is the SCCR rating has to be what it is based on where this equipment is going to be located, that type of scenario. So probably designers should be asking the SCCR value or trying to get that from the HVAC people right up front, especially if they know that this is going to be an issue. And obviously this is an issue. Next, inspectors. Now, the electrical inspector, the task they have in itself is evaluating a building and looking at everything, right? But they don't typically stop and check the fusing and circuit breaker sizing and specifically look to verify SCCR ratings and the available fault currents at this location. They assume that that's been done. They're looking to see whether the fuses or circuit breaker are protecting the conductor, because that's what it's there to do, to protect the conductor, and probably by vicariously through that protection, it may also protect the equipment, but the real focus is to protect the wire and the conductors, right? So that's the overcurrent. So that's what they're looking for, making sure that everything's sized properly, that conductor is still going to be protected. So that's their daily job. They don't go around thinking about, this HVAC equipment has an SCCR rating less than what could be required. And also it's an industry thing because we require certain types of evaluations for certain equipment, but I'm not aware, unless I'm wrong here, and somebody will tell me in a follow-up post, is that I don't believe we have an SCCR mandates specifically driven in 442 HVAC equipment. I think it just follows the normal electrical equipment and normal stuff that would be SCCR. But we would argue that an HVAC unit is not electrical equipment. It connects to an electrical system, but it's not the same. So we cover the fuses, we cover the disconnects, we cover the breakers, we cover all of those type of things which are electrical with an SCCR rating and have to worry about, in many cases, available fault current, but we don't think that much about the actual HVAC unit. Now, contractors, they may assume that the fuses fixes everything, right? But the fact of the matter is that the let-through still happens before the fuse opens. And so the factory-listed SCCR is the controlling factor in, again, that is to allow a certain amount of current to be presented and not blow up the equipment. Well, if that thing is only rated for 5,000 amps and 18,000 is getting through, then that's going to get through before the fuse blows. Then you still pose a risk due to the components and everything is in the SCCR rating only being 5,000. Again, I'm not seeing a lot of this in the industry. I'm not seeing a lot of failures that people are complaining and arguing, but there is a possibility for this issue, right? So one of the ways that we can fix this is that we need to specify an SCCR rating on any submittal. So any of that EE, any of the submittals you submit in, and you know what the available fault current, then you need to submit for a certain value. And then let the manufacturers of the equipment say, oh, we don't do that. Or you got to pay extra for this. Or it's another evaluation for this. Because you're asking them to give me the rationale, and maybe they've done some testing. We're in series testing and all this kind of stuff, like with the regular circuit breaker behind a main breaker. Maybe they've done some testing. I'm just not aware of it. Okay, I'm not smart enough for that. I'm not that intelligent to be able to give you an answer on that. But when it comes to the HVAC equipment, if it's posted at 5,000 amps and it's being put at a location that could present to it the available fault current much higher than that, then that seems a problem to me. So if I know this is an issue, then I'm going to specify an SCCR rating on a submittal, just like we would do for panels, just like we would do for control panels. We're going to force the HVAC manufacturers to list the equipment accordingly, right? And this might spawn change into the industry where the manufacturers say, okay, we need to kind of create these SCCR ratings that are more in line with panel boards, control panels, and all this type of stuff. Unless, again, they've done some testing where it's downstream and it supposedly dissipates out enough that it's not an issue by the time it gets to the equipment. Again, I'm not smart enough to know if they do that. I don't research that. That's not my thing, right? I don't daily think about that kind of stuff, and I'm not the smartest one out there. There's other educators that may have a better answer for that, but I don't have a better answer for that. And also, at the end of the day, document the available fault current. And again, one of the things that you're going to do if you're a plan reviewer, EE, or designing something, is just ask for the information from the HVAC manufacturer to make sure that they have accommodated the available fault current and what the rating in SCCR is at the location where this equipment is being installed, if you're concerned about it. Because I'm telling you, the industry itself obviously have been doing this for years and not concerning themselves with it. So it makes me believe there's got to be something behind it that the manufacturers say, look, we're series rated or something, whatever it may be. I don't know the answer. So I cannot be that much of a help to you. I just kind of gave you some thoughts on that, right? It says, let's see here. He says, I think this is a massive whiff in the whole industry that is hardly picked up by designers and inspectors. What are my thoughts? Well, those were my thoughts. You asked for it. If the available fault current at this equipment exceeds 5,000 and the standard is 5,000, then that's a problem. Does the NEC mandate fusing? Again, depending on what the available fault current is and the fuse, it may or may not provide that level of protection that's necessary. So is there something that needs to be done in the industry? I don't know. I'm not smart enough in that field to be able to know that. All I know that people are installing HVAC, rooftop units, CPUs all the time. All the time. And I'm not seeing a big issue. I'm not seeing people. I mean, look, somebody got electrocuted for carring in a crawl space on a 120 volt lighting outlet, and that got in the code. Or somebody got hurt leaning over an outdoor HVAC unit, and that's what spawned 210.8F to have GFCI protections. You know what I'm saying? People got shocked by supposedly ranges and ovens or whatnot, and that spawned the change for GFCI expansion. I don't know. I don't know enough about this topic to say that this is a big issue. But I can tell you, just on the surface, if the available fault current at an HVAC unit is 18,000 amps and your SCCR rating for the equipment is only 5,000 amps, that's a problem. And if putting a fuse on it can help mitigate it to an extent, okay, maybe that'll work. But because of how those fuses are rated, that type of thing, there's still going to be a certain amount of let through that gets through that could cause a problem. Hey, it may not cause the equipment to blow up, and maybe that's the effort. Maybe that's the goal. But again, this engineer puts disconnects, which is probably an extra element that helps them sleep at night. Hey, I'm all for it. Maybe something should be submitted. But it is a fact that amount of let through current instantly before the fuse blows could be exceedingly higher than the rating of the equipment, and then cause the equipment to have a problem or burn up. Again, I don't know enough on it, how quickly, what the let through, the reaction time is very quick with an overcurrent protective device. So it may be that mitigates it down. If anybody out there knows deeper than that, please let me know. And I think one of the biggest things that we have to understand is we're still sitting on a violation. We're still violating 110.10. So even though you're adding current limited fuses or circuit breakers, and it can limit the energy, the let through energy. But the key crux here is that doing so is something that you're doing as an engineer, and it does not legally raise any SCCR rating of the equipment itself, unless the equipment manufacturer tested and listed it with that specific fuse or circuit breaker and marked it accordingly to be something that does raise the SCCR rating. Otherwise, you're still having a violation of NEC 110.10 because the equipment is exposed to available fault current above its SCCR rating, regardless of that let-through energy. It's still going to be a violation of 110.10. So adding the fuses, because there's a lack in the industry, maybe a solution, a temporary solution to a bigger problem. Now, SCCR, for those that aren't familiar with that is based on a maximum fault current the equipment can withstand, okay, without any catastrophic failure during the clearing time process of an overcurrent protective device, okay, because you have this various clearing times. Now, current limiting devices, we can talk about, for example, like Class J fuses, RK1, LT fuses, and certain MCCBs, various types. Again, in some of those with adjustable trip curves, okay, they can reduce the I squared T, okay, that's the current squared times time, that peak let-through current gets through, okay? They can indeed limit that, but the first cycle of a fault, which we call the half cycle, okay, can be tens and thousands of amps before the fuse even opens. So many HVAC components, especially the contactors, the control boards that may be mounted on it, the transformers that may be integral into the system, they can fail in that first cycle when exposed to currents beyond their design limits. Again, if they were limited to SCCR 5,000, okay? Even if the total energy let through happens to be reduced, it still can cause an issue and still can cause things to blow up and cause a hazard, right? So as far as the NEC is concerned in the UL perspective, NEC 110.10 cares only about the total total fault current available, okay? Not about energy mitigation, okay? It only cares about the total fault current available. UL 1995 and UL 60335-2-40, which again, I am not familiar with. I pulled that up in doing some research. That requires HVAC assemblies to be tested and marked with an SCCR based on what they can survive with listed overcurrent protected devices. And obviously the standard we've learned as the industry is 5,000 amps, right? Now, you can't just say, I installed a fuse. This engineer is doing this for his own, comfort. And I don't think he's doing this, but he's not saying I installed a fuse or I mandate that you install a fuse, but you just ignore the SCCR nameplate, okay? Because the markings is governed by industry compliance, right? So again, the rating of the nameplate is what it is. It's what it was evaluated to, okay? So the bottom line takeaways that I want to think about is an HVAC unit marked 5KA SCCR and has a 30,000 amp available fault current that is fused with Class J. That is not compliant. It's not going to meet anything to do with the SCCR rate. It's going to be a violation of 110.10. Why? Because the SCCR is too low regardless of the fuse. It needs a factory listing in order to raise the SCCR value. Now, if you have an HVAC unit marked with 30,000 amps SCCR with a Class J fuse, guess what? That's compliant. Why? Because the manufacturer has tested with a Class J, okay, and the proper SCCR markings are on the enclosure, okay? That would be compliant. Now, if I have an HVAC unit marked for 5K or 5,000 amps SCCR, and it has a low available fault current at 4,000 amps based on, how far it progresses into the building or into the structure where the available fault current drops, well, then that's okay because that fault current is within the SCCR rating. That's not an issue. So I think a lot of this, and you say 5,000 is too low, it's really going to be dependent on where it's installed into the system. And I think a lot of this HVAC industry thinks that, well, look, it's coming in through the service, it's going into the main panel, it's probably hitting a feeder, it's coming out, then it's going to, it's traveling further into the building, and that's probably why the 5,000 amps has always been adequate. I don't know. I don't do these testing, so I can't say that. Now, field fusing without the SCCR markings increased means you just putting a fuse in it. It still doesn't make it compliant, right? Because the SCCR is still limited by the nameplate rating. That's the deal, okay? Now, practicalness, you can mitigate energy with current limiting fuses to reduce the damage, okay? Overall damage to people involved in it, right? But you cannot claim that it's code compliant on SCCR unless the nameplate actually says it is so. So no adding of the fuses is going to change any of that in the equation, right? So the big question that people ask me or will ask me, this gentleman may ask me, is, well, do fuses or circuit breakers hurt anything? Yeah, as long as you're not claiming to change the SCCR rating and you've done an evaluation and the available fault current at that HVAC equipment is higher than the 5,000, then putting the fuses in there are not going to do anything but probably save a massive issue, but it's certainly not going to save equipment, and there's still going to be issues because of that 5,000 SCCR rating. I can't tell you what the effects will be. Okay, I'm not sure like what will blow up and what won't, but what I can tell you is that even if it's not going to change the SCCR rating and you know there's an industry issue, I encourage you to still recommend the fuses and circuit breakers as well, because they will help, because they're going to reduce the damage potential. Even if they don't fix the SCCR compliance issue, they will help address it. Why? Well, because current limiting fuses and breakers reduce the peak current, that let-through current during the short circuit event. Again, may not save the equipment, may not save the contactors, the relays, the transformer, may not save that. Okay. And what this means is that the severity of the fault on the equipment is going to be lessened. And it may be a replaceable thing. It may be able to, you can place a transformer, whatever that thing, okay? You may prevent the explosion, the fire, or catastrophe or catastrophic failure, even when the SCCR is technically too low. It may help in the condition. It's certainly not going to hurt it, okay? Okay, so it kind of, and I don't know an example. If I think of a mental picture example, I think of it like wearing a seatbelt in a crash, right? It doesn't change the fact that you hit a wall at 60 miles per hour, but it reduces the chance of a fatality. So it doesn't solve the SCCR rating. It's better than nothing. If there's a issue in the industry and your available fault current at the point we are can exceed the rating of the HVAC equipment, then it would probably be prudent to add some currenting limiting device, circuit breaker or fuse in the system in order to limit the damage. Not totally remove it, limit the damage, right? But at the end of the day, we have to think about code enforcement. You're still going to get issues because 110.10 doesn't care just about the reduced damage, right? It doesn't care about that it could be less than it could be. It doesn't care about that. It requires the equipment to be available to withstand the available fault current without failing, which is why the SCCR nameplate governs this compliance, okay? It's been evaluated for it, okay? Now, in a lawsuit, okay, a post-incident investigation, we call it, you can't defend it by saying, I installed current limiting fuses, even if the available fault current exceeds the SCCR rating of the equipment. That's not a valid legal argument. You're going to lose that argument. So the best thing you can do is say, hey, if I've got 18,000 amps here, this unit is rated for 5,000 amps. I know that it's 18,000 amps here. It's exceeding its SCCR rating. Mr. Manufacturer, do you have anything that will accommodate 18,000 amps? If their answer is no, then all of you have to make the decision to put in fuses to at least mitigate some of the damage. Not remove it all, but mitigate it, okay? So I kind of tell you have to think of this in layers, like a cake, right? Whereas fuses installed when you have an SCCR that's too low, the outcome, the equipment may survive, but risks still remain. Is that compliant with 110.10? No. So maybe that's the compromise. The next thought is, okay, well, I'll put fuses are installed, and it is a proper SCCR marked properly. Well, if that's the case, then the equipment will survive and it complies with the code and it meets 110.10. And that means that you ask the manufacturer of the HVAC equipment to increase the SCCR rating on that equipment or whatever they have to do accordingly, okay? Or tell you what you can do in order to do that, okay? Now, the worst case scenario is you have no fuses. So you as an engineer are installing these fuses. Again, I think that's the right thing to do. It's not going to solve it all, but it may mitigate some of the risks, some of it. Still not compliant, but mitigates some of the risks from an engineer's design standpoint. Now, you do no fuses and that SCCR rating is too low based on the available fault current, then you have a high risk of catastrophic failure. It's certainly not compliant, right? So bottom line, yes, fuses help reduce the real-world risk. It doesn't eliminate it. But bear in mind that the National Electrical Code is a minimum safety standard. It doesn't mitigate all risks 100%. It's a minimum safety standard. So I definitely agree with the fuse in light of this is the case. But bottom line, no, they don't fix the compliance gap with the equipment. That's something that needs to be a communication with the manufacturers of the HVAC equipment, right? So practical reasons, fuses are better than nothing, okay? But for pure compliance and liability issues, you need to make the manufacturers come up to speed with these SCCR ratings based on the location, unless they're saying that the 5,000 is based on how deep it is in the system where the available fault current drops rapidly as it moves further into the system, that type of thing, okay? All right, that's a lot of information. Again, I'm going to argue it with everybody and say I am not the expert on these things with HVAC equipments. I'm just assuming 5,000. I'm sure they make a higher SCCR rating. That's just the industry standard is what I'm reading and what I'm hearing. And it correlates with what the engineer that sent the question in. So my thoughts are recommendations. And again, you can say, I'm just saying if there's nothing to be done, fuses or current limiting devices can help. It's not going to mitigate it all, but it can help. And we're just not seeing a big issue in the industry of the faults blowing things up and this being the result because of the SCCR rating of the equipment. There's usually bigger issues or bigger fish to fry. How do you change this? Push back to the manufacturers. If you're worried about the available fault current at a piece of equipment, even in areas where the NEC doesn't stipulate that you have to be aware of available fault current, okay? I'm just saying, if you're concerned and your design is concerned with the short circuit current rating of equipment and where they're located on the system, then you have to push back. You have to push back from the manufacturers. And also, if it's a known issue, you need to think about presenting public inputs and to the code development process. I can't do that. I don't know that industry or work closely with those types of equipments when it comes to that. But if you are one of those, then you need to deal more with it. You need to get more involved. Otherwise, we're not going to solve the problem if there's a problem there. You get me? Okay. Anyway, I don't know that I answered your question. I did a lot of talking, and I probably bored a lot of people. And again, you don't need to get nasty with me. I have told you over and over, I am not an expert when it comes to HVAC, how they're constructed, what their short circuit current rating is. I can only speak about what I know, and that's it. Till next time, folks, stay safe. God bless, and we'll catch you on another episode of Let's Ask Paul. Peace.